Hello, everyone, and welcome to this session, which I am not totally sure what will be. So, the idea behind this session is that I'm basically just going to stand there and talk about Kubernetes stuff, and hopefully, someone will ask some questions, bring up some things they want to do. But I also have some basic demos of stuff. So, let me just put it this way: I have no clue what this session will be. We'll figure it out as we go along. I'm going to be 100% in terminal, so I needed some sort of slide just to introduce myself. So I got these. My name is Robert. I work for Supersteria, based out of Oslo here in Norway. I have a fancy title. I made it myself. My official title is very boring. So since I'm a consultant, I can just make up stuff. So I did. I've been doing I've been doing Kubernetes since basically my entire career at this point, and I've been very active in community stuff, doing stuff like this. And for that, I have got the Microsoft MVP title. Even though I mostly do stuff that's totally open source and not really related to Microsoft stuff, but I live in Norway, so everything's on Azure. So that was kind of like the thing that I've been showing off. So that's why I'm a Microsoft MVP. I'm also a CNCF ambassador. I've been in the CNCF for 4 years, done some stuff you might have heard of. I helped define what GitOps was by helping writing the GitOps principles. I created and led the platforms working group for a while, and from the platforms working group there was a platforms white paper, platform engineering maturity model, etc., etc. A lot of these resources that people use in their day-to-day when it comes to building platforms and stuff like that. I'm not taking any credit for that. Everyone else did a good job, and I just looked at it and went like, this seems cool. I've been doing that for a couple of years, and then I became the chair of Tag App Delivery, which now doesn't exist anymore, which is kind of sad, but there's a restructuring going on, and I have no clue what that looks like. So if anyone wants to join the CNCF, this is a good time because everything is uprooted. Let's not talk too much about me. Let's chat about other stuff. So just quick raise of hands. How many here are developers? Yeah, I figured. Weird. How many here consider themselves ops? Yeah, all right. Hey. How's it going? This is going to be mainly geared towards developers. There's a lot of when I talk about Kubernetes with developers, it's usually some sort of it's hard, it's difficult, and so on and so forth. I hope to show that that's not really true. But speaking of which, how many here are experienced with Kubernetes? All right, good. That means you will learn stuff. And by experience, that means just are you using Kubernetes? Are you developing applications? Are you developing applications that are running on Kubernetes now? Okay, cool. Which is good. Again, you will learn a lot. Of those of you who are running stuff on Kubernetes, could you yell out some pain points, stuff that makes it difficult? See, it's a perfect system. No one. Does anyone here find the? I guess containers aren't that difficult, right? But how does that run on Kubernetes? Is that something that's unclear? All right, cool. Good. I can just do everything there, all the basics, and then I'm done. No, so like I said, the entire idea behind this session is it is interactive. So I have some stuff that I want to go through, but the more people yell at me to do other things, I will do that. I have ADHD, and my medicine ran out a couple hours ago, so we'll see what happens. So we're gonna do a demo now. All right. Let me just explain what you're looking at. In the top left, which is basically the entire screen, that's NeoVim. On the top right, which is not that big, is a tool called K9S, which for those of you who haven't been using Kubernetes, if you start looking at how to do stuff in Kubernetes, there's going to be a lot of kubectl commands, right? They get slightly weird after a while. You start going blind looking at them. They do all this kind of weird stuff. K9S is a CLI or a graphical text-based tool, whatever you call that these days, terminal UI, which will kind of show you what's going on. So it's much easier to interact with your Kubernetes cluster in this way. And it's also much easier for me who do demos because I can actually show something and not just like a text that barely anyone can read. It's probably a little bit small right now. I'll bring it up to size if there's anything to look at. I'm just making sure that the Kubernetes cluster is actually running at this point, which it might or might not be. I'm going to be running things locally just because. So I used a tool called Kind, which is Kubernetes in Docker, which is kind of funny because I'm not using Docker. I'm using something called Colima, which is containers on Linux machine something. So it's a thing on a thing on a thing on a thing on a thing running on a Mac. All in all, that works well, except sometimes it doesn't start up. So I'm really happy that it did because I don't have an alternative. That would have been bad. So we're going to run stuff on a cluster locally. We are going to look at my amazing application. I am not a developer by trade. I like to, I try my best, but it is what it is. So my amazing application is a Go application using Go Fiber, which is an easy way of doing APIs and web stuff. Even though Go kind of do that pretty easily by itself. I just found this at some point and figured I thought it was cool. So that's why I'm using it. I don't have a strong opinion on these things. So if anyone goes like, oh, you're using Fiber, well, yeah, that's what I'm doing. There's basically, for you developers, you all know this. It's basically just run up a server which has some endpoints. I have a couple of things here. I have one API endpoint, which basically just says hello world if you hit it. I have a public folder which I'm putting stuff in. By putting stuff, I have an HTML file. That's the base of my front-end development skills. So I had to put something in there. But more importantly, if you're doing stuff in the Kubernetes world, I have a health endpoint. It's called that because someone figured it was going to be called that in the Kubernetes project, so it's called health. I guess just to not be be a little bit unique. And all that does is just yell out, everything's okay. Why? Because we are going to use it later to check if everything is okay. So, it's a good thing to have. Other than that, not a big deal. So that is my application, if you want to call it that. Also, I'm going to be pretty hunchback because this is way lower than I need it to be, but okay. I build my container in the easiest fashion. I even label it that I'm the maintainer. Why not? And I do various stuff. This is not optimal. So if you're looking at this and go like, this is how I'm supposed to do containers, don't do it like this. This is a demo. This is me just trying to get something to run on Kubernetes so you can look at something running on Kubernetes. Yeah, so basically, the server port is 9020. Does anyone know what like 9,000 series zip codes is? No, they're all Southerners. Huh? Tromsø. Yeah, I'm from Tromsø. 9020 is the zip code of Tromsdalen, where I'm from. So I just keep on using that number because I remember it. Been writing it my entire life, so It's great. I have a new one now that I live in Oslo, but I'm not going to disclose that. It's a pretty small area, so don't come visit unless you call first. Anyway, so I have an application. I have a Docker file. I built it. I'm not going to build it here because you know how to build stuff, I hope. And also, this is not to talk about building things, which is why this is really bad. What we are going to look at is how do we get this into a Kubernetes cluster. So I have a Kubernetes cluster now on the right, which is working, it seems, which is good. I cheated a little bit. So I had a cluster running. I've done a lot of work before I came here, up until the point where I had to run to get here, trying to get all the demos to work. So that's why I haven't done too much with this cluster right now. I'm not touching it. I'm just going to show it off, and then we're going to try to do stuff from the bottom up. So as you can see, or maybe not, we have stuff in here. Kubernetes works in it's containers, right? But it's not called containers in Kubernetes. It's called pods. Pods is a set of or a group of containers. Why is it called a pod? Because a group of whales are a pod. We're really good with names and stuff like that. So it's not a container group or something that makes sense. It's pods, right? So usually, if you deploy stuff in Kubernetes into pods, you deploy maybe one container, and that's it. It's still going to be a pod, and that's fine. But the added benefit here is that you can also add several containers into that one pod and do stuff like share resources between them. And that's where we get stuff like sidecar containers, where you can, for instance, if you want to do logging, for instance, instead of writing that into your code, you can put a sidecar container in and do all that logic there and not touch your application code, which is great. Not always the best approach, but it is a great alternative, and we use that a lot. So on the, as you can see now, we have some stuff in here. There are a bunch of namespaces, which is where you put your pods or all the resources. So you know, a little bit of note here, like it's namespace and you separate out things, right? You can set up some logic to kind of make sure that stuff doesn't, like traffic-wise, go between namespaces. But this is a soft security thing. It's not like you can have a bunch of people and have them on the same Kubernetes cluster and then have namespaces and then everything's going to be securely fit into these packages. So it's a soft thing, right? This is more to organize your things, to put in, if you have various teams and stuff like that, you can do stuff like that. If you need hard security stuff, you need to have different clusters. That's a whole other talk. I'm not going to go into that, but we have namespaces. That was the point. And we can see we have something called default. That is the default namespace. Weird. Also, don't put anything into the default namespace. That is a faux pas. You're not supposed to do that. Why do we have that? Well, just in case, I guess. I feel they could have removed it by now. You've been using the default namespace for 10 years. I don't know why we have it. But it's there. We also have things like the kube system, which is weirdly enough where all the system stuff for the Kubernetes is running. Yeah. And then we have some other things. And these are, we have kube public, which is also a thing you probably shouldn't use. This is related to the fact that I'm spinning this up in kind. That and that. It's basically just stuff that kind puts in to make sure everything works. So don't worry about that. That is a kind specific thing. You don't necessarily see that in other providers. You will see other things that are not directly tied into Kubernetes itself. So, with all of that said, we do have some that are kind of important. We have this web app one. That is my web app, if you can call it a web app. It's barely an app as it is, but okay. We have Cert Manager, because I left it in there, so okay. But we have Cert Manager. Cert Manager is great. We're going to come back to that. And then we have Flux system, and this is where I kind of want to get going. So Flux, for those who don't know, is a GitOps tool. And in case you don't know what GitOps is, it is not to put stuff into Git and use pipelines and stuff like that. If you call that GitOps, you're wrong. Sorry. Not to be too harsh. A lot of people get it wrong. But GitOps is that you declare your desired state, or you have your desired state in a declarative fashion. You store it somewhere version in the mutable, Git. You automatically pull in the changes. Never push. If you're pushing with pipelines, you're not doing GitOps. So that's where stuff goes totally wrong. And you want to always try to reconcile, which is what we call it, automatically reconcile and apply the changes. So if anything changes in Git, that needs to be what's happening in your system. That is how it works. So if I do a change and push it up to Git, I should know that that is what is the current state of the cluster whenever that picks up. So Flux is the first GitOps tool and kind of where this all came from, basically. So they kind of invented the word. A lot of you probably, if you're looking into GitOps, you probably heard of Argo. Argo is a very developer-centric tooling, which is why a lot of you are probably going to end up using Argo. I am a platform engineer, and Flux is more of a platform engineering tool. They cater to two different audiences. So the Argo puts on a lot of stuff to abstract away Kubernetes. Flux, you point it towards a place where you have Kubernetes manifest, and it applies. That's it. So, well, more or less. So we have our Flux system. So I already have run the process of getting this GitOps. And if you look at I don't know if that's big or small for you people. Is that good? It's a good size? Cool. In my folder, or my Git repository, I have apps, clusters, and public. Public is, this great thing. So don't think about that. That's not important. Look away from the bad development stuff. But we have apps and we have clusters. When it comes to setting up GitOps, or at least Flux, the fun thing is that everything will work, no matter what you do. If you point it at the root of the Git repository and put your manifest there, it's going to work. If you have just plain Kubernetes manifest and put it in there, it's going to work. If you template it with Kustomize, which is what we're going to look at because it's a little bit more fun, it's going to work. There's no best practices per se. I also don't like that word, but everything will work no matter what you do. So this is just how do you structure your system configurations. But a very common way of doing it is having a folder called clusters. And instead of clusters, we have a folder per environment. It's also very common not to use branches while doing GitOps because you probably just need to put stuff into one branch and keep it to that. And a lot of the things that we do when it comes to doing cool stuff on automated release cycles and stuff like that, that is things that we add on top, but we want, the entire idea about GitOps is that it should just work. It's deployment is not something you need to think about. You do all your hard work and then you have a container. When that is ready to be deployed, that should just deploy. So, so we have our dev folder and our prod folder. Prod folder is going to be empty. The dev folder is going to have stuff in it. And with some exceptions there, you could kind of see some of these namespaces go back. So cert manager, that's the namespace. Flux system, that's the namespace. Web app, that's the namespace. So the way we usually structure this is by putting it into folders and named by the namespace because that just makes sense. It's kind of tying it all together, right? You could, like I said, have just a bunch of Kubernetes manifest in one folder. That's not going to be fun. It's going to be okay when you're deploying your test stuff. So it probably would have been okay for what I'm doing right now. But as soon as everyone starts doing stuff and you get 1,000 resources or something to that, you're not going to find anything. So why not just start off doing it in a better fashion? I don't know. If we look at Flux system, we can see there's two very important things there. First of all, there's a bunch of files there. They're all part of the deployment. But the main important part is that we are not going to use normal Kubernetes manifests. Normal Kubernetes manifest is just like YAML that declares this is what's going on. What we're going to use is Kustomize. Kustomize is a tool from the Kubernetes project. It's part of the Kubernetes CLI SIG, that's special interest group, so the people who actually wrote kubectl. It's integrated into kubectl, so you can deploy stuff in a templated fashion just by using CLI tooling. Like I said, the main thing here is that you don't necessarily have the normal structure. So if we have to set up things in a special way. So we have a customization file. That means this entire folder is a customization deployment. If you look at that, it says these are the two files that are resources. And if you look at them, now this is going to get weird. This is generated by Flux. And as it says somewhere here, yeah, do not edit, it says on top, because you're not supposed to edit this. This is generated by Flux, based out of like a lot of, pulling stuff from the internet and doing stuff. We don't want to edit this. Also, it's not short, this thing. Oh, let's do that. It's, yeah. So don't edit this, because it gets weird. You don't need to know what all these do. It's basically just this is how we declare stuff in various fashions. I'm going to come into some of these things in a little bit, but we don't need to look at this. This makes no sense. What we would rather look at is, for instance, my awesome web app. And what we see here is this is where my cluster is pointed towards. When you look at this, you can see I have stuff like common labels, which means basically just it's going to put certain labels on everything. And it says bases. Shouldn't be that. That's actually deprecated. Sorry, I forgot to update that. Or resources, which is a new thing. And then it's pointing towards the apps folder. And if you look at the apps folder, if I can actually... We have basically the same things here, but there's a lot more in here. So if you look at the customization for it, for this folder, we have all our files added. If I look at, for instance, namespace, this is how you define a namespace in Kubernetes. So instead of having everything where you're pointing your environments, we put this in a separate place. It doesn't necessarily have to be named this. The customer that I'm at currently have like a bunch of different layers because we have a bunch of different stuff going on. But all in all, we just call this kind of like the base deployment. This is the entire thing, right? So if we look at the deployment, and this is how we write a deployment file in Kubernetes, we have all the things that you would need to have. Including stuff like probes. I'm going to talk a little bit about probes in a little bit. But so the basic idea is we keep our setup dry. Don't repeat yourself by having a base, and the clusters themselves are going to be pointed towards the base, and then you can add stuff on top of it if you need to change it based on the environment. So if you have multiple environments or multiple teams doing stuff in multiple places, you could have one base deployment for everything. And then you would add the changes on top. For instance, a different version of the container that you're going to run. Stuff like that. So you can have that, in the ease of having like that one deployment file, but also you can customize things based on what you need. So probes. This is one thing besides not deploying to default namespace. Like if I'm doing like a second opinion thing and looking at a cluster, the first thing that I look at is default namespace. Is there stuff there? Yes. Well, okay. Probably just burn the rest at that point. The second thing is Kubernetes is great. Like it scales, it makes sure that everything has the resources it needs, et cetera, et cetera, et cetera. But if you don't set some guidelines for how it's supposed to interact, how it's supposed to take the things that you want to run, the workloads, and find a spot for it, it's going to do as best as it can, which is not what we want when we're doing like big production services, right? We don't want best effort. We want it to be actually up and running. So one of the things that people forget is probes. Sorry. So there's 3 probes. I only have 2 here because I only need 2. You have what's not in here is a startup probe, which basically you can tell Kubernetes that stuff has started up. I rarely use it, but there are times where it comes in handy. I can't think of a single example at the moment. Then you have the liveness probe. Liveness probe is so the Kubernetes can see that your application is actually running. Your application might have gone off the deep end and stopped, or it's not working properly, but it haven't sent like I'm needed to be terminated type thing. So Kubernetes is just going to continue to run that pod, and then you will have failures and stuff like that. So by setting a liveness probe, this is a point of contact where Kubernetes can look to see if everything is okay. If not, it's gonna attempt to restart the pod, so you don't have to, all right? There's a lot of that in Kubernetes. They do stuff so you don't have to. Right? Readiness probe is kind of the same thing, and as you can see here, I'm kind of just pointing it towards the same HTTP endpoint, which for my application doesn't matter because it's barely an application again, but that might differ in your case. Readiness probe is you're basically telling Kubernetes, is this pod ready to receive traffic? Which again is kind of important, right? So you might have a pod that's spin up and there's a bunch of things that it needs to go through and is not ready to receive traffic. But if you don't tell Kubernetes where to look for the OK, it's going to start routing traffic in, right? And that's not great. So when you're scaling up, think of Uber. I know no one works at a company like Uber, but if Uber needs to scale up, they can't push all these pods up and have them not be ready to receive traffic, and people go on their app and go, I can't find any cars. That's not great. So with Readiness Probe, we can combat that. The way that networking works is what's kind of funny about Kubernetes is it's 10 years old. It's still using the things that we have been using since the 70s, right? So one of the main things about Kubernetes is service discovery. Do you know what service discovery means? DNS. That's service discovery. It's basically just, right now, my Kubernetes cluster's name .cluster.local, right? Put in front of that the namespace, put in front of that the service or deployment or whatever you want to point towards, and that's how you discover your services, right? Networking, IP tables, still. So it's all kind of just like basic things that we've always been doing, but it's been abstracted away into this platform. And stuff like Readiness Probe and things like that is what kind of makes it smart. But one of the ways, you could point your traffic directly towards a pod, but that's not going to really scale, right? You don't want to be dependent on that one pod, because in the cloud native world, everything is immutable, and you should not care if it is removed or something like that. You need to be able to just remove the entire pod and everything will work by itself. So that's where we have service. And a service is basically, I don't want to call it a load balancer because it's not. It's not a load balancer, but it's kind of like the same concept. It's one point where you send your traffic, and then based on, in this case, a selector that looks for labels, it knows where to send the traffic. So if we look at, if I can, thank you. If we look at the services running here, let's do that-ish, and sort of. I'm always a little bit hesitant about zooming in and stuff because sometimes my terminal goes haywire. These are all the services in the cluster. we have one for Cert Manager. We have for kubedns, like I said, it's basically just DNS. We have some stuff from Flux, but we also have my web app. So this is where you would enter to see my awesome app. And as you can see here, it's IPv4. Kubernetes also supports IPv6, but I guess, you know, it's, again, this is why we abstract things away from developers. You don't need to think about that. It takes traffic, okay? And it's on the port, the great port of 9020. And so if I press enter on it, it's actually just going to spit out my 3 running pods. Right? So this service just looks at the labels and then knows these are the pods. And as you can see, the pod names are, I have a prefix for dev in this case, the name of the application, which is called demo, a great name. Then it has a long random thing, followed by another not so long random thing. The long random thing is because I have it was really hard typing all the time like this, because I have a deployment. So I'm not putting out a pod or X number of pod. What I'm doing is I'm defining my deployment. And my deployment is this is the pods, this is how many I want of them. I want 3 pods to make my awesome app available, stuff like that. And as you can see here, we have 3 of 3 ready. 3 of them are up to date, 3 are available. If you look at some of these things that the deployment cares about, we have stuff like what type of strategy are you using if you want to update it? And in this case, or by default, it's a rolling update, which means if you're updating to a new version, it's going to start spitting out new versions and then taking away the old ones, right? So it's going to roll. 25% max unavailable, 25 max search. So it just limits how many will be deleted at any point. And then we have a pod template, and these are my pods. Right, so this is what you would have defined as a normal pod, but you don't do that, you define it in a deployment. All right, so if I go back to pods, that's the first number. That is the current deployment. So if there is a update and there's the deployment is going to roll, the new pods are going to be called dev-demo-something new, right? And then the last number is every single pod's unique hash. Because again, we don't name them, we don't really care. We just label them and like so we know where to go to, you know, find all defaults. And that's basically how deployments work. Again, it's an abstract of an abstract of an abstract, but again, containers are running in pods. You could put out a pod, but that you won't be able to work with that in the long run, which is why we have stuff like deployments, which funnily is an abstraction on top of another thing. So the scaling part is its own resource, but it turns out that wasn't a great thing to deal with, so they made deployment to be an abstraction on top of the abstraction on top, etc. So the alternative here is stateful set. Stateful set, as it sounds, is a set of pods that are stateful. So if you need to remember the pods, if you have storage and so on and so forth, I prefer my pods to be stateless. You know, have data somewhere else, right? Sometimes that doesn't work. That's why we have stateful sets. So instead of having these random numbers, it will be labeled 0, 1, 2, 3, etc., and we'll remember where the volumes that it would have mounted would be, and so on and so forth. And the last type of deployment is daemon set, which runs on all the different nodes. So if you have X number of nodes, this is going to always pop up on every node, which is how you do some logging things and security stuff, right? So on and so forth. So I'll just check time. All right. So that's deployments in a nutshell. All right. So we have this structure. We have our clusters defined. And then we're using Flux to do the application of the manifest. So how does that work? Well, if I, first of all, change to the Flux system namespace, and instead of having all the generated names, let's look at the deployments because it makes it easier. We have 4 controllers. In the Kubernetes world, everything is run by a controller. This is how we do everything. We put stuff in the Kubernetes API, and then controllers are looking at it, watching it, and if there's a change, that applies stuff in the Kubernetes cluster, which is why the GitOps model kind of just came from, because that makes a lot of sense, so they did that for deployments. In Kubernetes, you have your resources. I talked about services, I talked about pod. All those are resources in the Kubernetes cluster. What we also can is add our own custom resources. That horrible YAML thing you were looking at earlier was a custom resource. I don't recommend writing your custom resource unless you know what you're doing. I can barely read it, and I've been doing this for a while, and I actually create stuff like that. So use tools to generate things, more or less. But by having these custom resources, you can have your own controllers to do basically whatever you want. You can automate everything by doing it like this. And Flux have 4 controllers. It has a source controller, which is the one that controls the source. Good name. So that looks at Git. Every time there's a change in Git, it pulls down the entire Git repository and stores it as an artifact on the cluster for everything else to use. Then you have the notification controller. I'm going to go through this in a specific fashion because I'm going to get to something that kind of doesn't make sense. Notification controller, it notificate you, whatever that's supposed to be in English. And funnily enough, it does extra stuff. I'm not going to get into that. I'm trying to control myself. I get excited. And then you have the Helm controller. And if you have looked at Kubernetes stuff, Helm is usually something that pops up as a way to do templated deployments. Please don't use that if you're just doing normal deployments, because Helm is difficult, or it gets difficult. It gets weird. A lot of people have issues when they start writing their own Helm charts. Helm is something if you're creating something that you want a lot of people to install on a lot of clusters, like Cert Manager, for instance. Cert Manager have Helm charts. All these tools that Flux have, well, actually Flux doesn't really have a Helm chart, but anyway, bad example. All these tools have Helm charts, so you can more easily deploy stuff in your cluster, because it took used a ton of time to create all the complexity at the back. So the Helm controller here is to deploy Helm charts, basically it basically just runs the Helm CLI command. You define how you want that to be run, and it kind of just runs Helm. And then at the end we have Kustomize controller. And I've been talking about customization and Kustomize. And in Flux world, it's called Kustomize. It kind of doesn't make sense. It's kind of using a name that's already taken. And the thing is, the Kustomize controller is the one that does the kubectl work. So it's kubectl apply on all your files, wherever you want that to be. But it also supports Kustomize, the templating language. So they called it that. Which gets confusing for me and probably for you as well when I start talking about some of these things, because how do we set up our reconciliation loop with Flux? By creating okay, cool. So for some reason I have Kustomize, but I don't have it. Hold on. Oh, okay. I have a failing customization. Well, we'll just talk about it. So the resource that we are using to do our reconciliation loop is called customizations. So we're using the resource customization to set up how we want to apply our stuff that might be running Kustomize, it might not be running Kustomize, et cetera, et cetera, et cetera. So for me who do presenting on these things, I wish to have a different name, right? Because I had to preface it with Flux. So we're going to set up a Flux customization. It's not a customization in a folder, which is Kustomize, right? So again, it gets confusing, but the idea is that this is where we set up what we want our reconciliation loop is, and since it doesn't work in our cluster, I'll do the, let's just look at it in plain text. So first of all, we have our resource for Git repository. This is what Flux set up to point towards my Git repository. It says branch here, and I said we only use main, but I do this demo, so I kind of need separate branches for that stuff. So again, this is not showing off all the best ways of doing stuff. Just do as I say, not as I do. So this is what the source controller looks at and pulls down every minute, right? So every minute it looks, checks if everything is still the same, it's not going to do anything. If it's a change there, it's going to pull in the entire Git repository and store that as an artifact. Then we have our customization, our Flux customization called Flux system, living in the namespace Flux system. We do that a lot in Kubernetes world. We have a lot of repeating names. You get used to it after a while. And this is set on an interval of 10 minutes. So every 10 minutes it's going to look or take the source artifact that we have downloaded. It's going to open it up. It's going to look into the folders, clusters/dev, and it's going to apply stuff. And that's basically it. That's deployment, right? It's magic. So the thing here is it's on a 10-minute cycle, and probably several of you are thinking about pipelines. You do your change and you see that it gets pushed through, and that's cool. Like I said, GitOps is that you pull in the changes from the source. The system needs to pull it in. That makes a lot of sense for a lot of reasons. You don't have a pipeline or other resource that needs to push something through, because if you're, for instance, running your pipelines in Azure DevOps or GitOps or something like that, and you have a Kubernetes cluster that shouldn't be on the internet or be accessible over the internet, to do those things, you actually need to be able to access the Kubernetes API, and you don't want that on the internet. That's bad. So by going from the system and pulling it in is much safer, and is also much easier. But again, it's on a time cycle. What you can do, though, is what we call event-based GitOps, where we set up the notification controller, again, should have a different name, to be a webhook. So, for instance, you do your change in GitHub, it can ping the webhook, and Flux goes like, oh, I need to reconcile right away. So as soon as you push your change, it's going to be reconciled, right? And that's basically how we do deployments in Kubernetes at the grand scale, except this is on a cluster. I'm just being cautious of time because I talk a lot and time are running out. All right. First of all, before I do anything else, is everything clear so far? Sort of? Okay? All right. So, again, feel free to ask me stuff after the session. At that point, I probably won't have any voice left, so it would be better if you asked it now. And you just yell out the question. All right, so we have our GitOps set up. We're doing our deployments. One thing that I probably should talk about on the deployment side. We have our probes, so Kubernetes knows what's going on. One thing that is extremely important that no one does because it's not out of the box is define the resources that your workload should be using. So Kubernetes is great at what's called the bin packing problem. You have X number of bins in various sizes, and you need to pack X number of items of various sizes into them the best way possible. Kubernetes does that brilliantly, except it actually doesn't know how much resources you need if you don't say this is how much resources it should have. So resources you define it by setting, well, you have the resource section here. I just have limits. That is the upper limit of what you need. The other thing is a request. So you can set your request to be, for instance, like in this case, it's in whatever measurement this is, so that's a half a CPU. You could start by 1/10 of a CPU. And that's just like to get stuff rolling, and then it will basically give it more resources as it needs up to the limit. If you just set limits, though, you're setting a static, this is what it has. So in many cases, this is a great thing to do if you have a very stable thing or just want make sure that everything makes sense. There's debates in the Kubernetes community about stuff like setting the CPU lower and scaling up and stuff, because CPUs don't kind of work like that. It works in mysterious ways. But let them argue about that. Please set your resource limits, because that's what Kubernetes looks at and says, all right, I have this thing of this size, and I have that amount of space available over here. Or else it's going to just try to do stuff. Worst case scenario, if you have no limits, you put it on a node that barely has room for it, doesn't know that it barely has room for it, and then all the workloads on that node starts using a whole lot more resources, then your node's going to go bye-bye. And that's not cool. We want our nodes to be up and running. That's where everything is happening, right? So, very important thing. Right. Another very important thing is, again, looking at time, and since we don't have questions, just mentioning it. We can look at Cert Manager, because that is a thing that it was one of the first things that kind of sold me on the Kubernetes thing, right? Because if you work in development, which most of you do, you know that you have to care about stuff like certificates, right? If you work in ops, you know you have to renew them. And then people forget. And your services are not available, or you can't connect between, and so on and so forth. It's really not that great. Cert Manager, as it says on the tin, is a certificate management application. What it does, it's using the Acme protocol, made kind of famous by Let's Encrypt, which just gives you certificates. So use Let's Encrypt, it's free. And you can just define, like, I have a web app, and that web app, I want that to be HTTPS, and it needs a certificate, and this is basically the domain and everything that you need. And it goes like, all right, cool. Now you have it, and it's also applied to the incoming traffic, and you don't have to think about it at all in any application side code or anything like that. What you do then, and I just realized I don't really have that much to show off from it. All right, cool. All right, I'm stealing this off the internet. Anyway, what you need to do, because you want traffic in, right? Again, you're developers, you want stuff into your Kubernetes clusters to show off your great web app. You need something that defines the entry point. You could use a service. So if I go into, if I can use my keyboard, if I look at my service, let's look at all the services. We have my web app, right? The web app service that points to the web app instances. And in this case, I said I have a port, it's 9020. What I could do is I could define this as a load balancer, and then the service actually becomes a load balancer. What I mean by that is Kubernetes is built for cloud. This came out of Google many years ago, and it's all modular. So every single part of this can get ripped out and be replaced by something else. when you say load balancer here, well, first of all, that's not going to work in my case because it's running on my machine. You could set up stuff for it. Never mind. If you run this on Azure and you say load balancer, Azure is going to create an Azure load balancer, and that will get a public IP, and you would have then exposed your service on the internet through an actual load balancer. If you're using Google, it's going to do the same, just with Google stuff. If you're using Amazon, et cetera, et cetera. So these components are interchangeable. And if what I can do, since I'm just connected directly to my cluster, I can use something called port forwarding to kind of like simulate that. So by pressing capital F in K9s, I get, well, it's kind of hard to read, but it basically just says the container port, which is it's referencing the actual container that I'm going to hit, because I could have multiple containers. 9020, that's good. Local port, 9020, that's also cool. And it's going to be on my address localhost. And if I do that, I can now, and hopefully I don't have anything sensitive up. If I can type, localhost 9020. That's my web app. It's great, right? What I could do is I could do /API, and it shows a less impressive web app. Or I can do hell. Oh, I can't spell. Well, I got an error. Cool. Again, I'm going to be hunchbacked after this. Oh, there you go. And it says OK. My web app is up and running. That is through the service, but this is not really that great if you're doing this in a cloud, right? You want a little bit more security than just like putting stuff on the internet again. So that's where we have, well, now we have two things. Originally, we only had something called an ingress. You define the ingress. The ingress would basically just be if you have this host name, based on certain patterns, point towards the service. And that's how we do it. And on the ingress side, you can actually then annotate it and say, I want this to have a certificate issued by Let's Encrypt. And you would just get that. Just imagine it, because I don't have any demo ready for it. Now we have something called API gateway API. And again, we're using same names of other things that already existed. So it's we're great at naming things, aren't we? But that is a new thing because the old ingress type was kind of clunky and is not really that great to work with in some cases. But again, since these are all just concepts spinning around in a Kubernetes cluster, this means that in any cloud that you're in, you could say, for instance, I want the ingress to be there. And you could directly tie it into the cloud vendor that you have, and they will just basically do everything and point the traffic in towards you. The ingress is not enough, though. You need to have something called an ingress controller. A very standard one is the Nginx ingress controller, and if you've done stuff with servers, you've probably heard of Nginx, which is basically just a web server. They were kind of the first to create an ingress controller, and that's why it's standard now. Everyone's just using that. There are others that could be better, so check that out if you want to do stuff. But you're probably going to end up using Nginx ingress controller anyway. But the point is that you set up your ingress. That ingress is going to point the traffic towards the ingress controller, and that ingress controller is then going to scale out to whatever is happening. So that's when you can do certain parts of the path has this in it, so you end up on a different service and stuff like that. So you can do more advanced stuff. And you also have an egress type thing, so you can do load balancing, so you can have a static IP of your web services and stuff like that. But again, that gets into like the nitty-gritty of things. Just know that it's there. And that's ingress and egress. And I have 5 minutes left. All right, since I have 5 minutes left, I can try to, right. What I can do, because it's the least effort, least effort, it's the least prone to fail. I have if I change my Kubernetes context, I have my production cluster that currently has nothing in it. So since there's only a couple of minutes left and you didn't see how Flux works, I'll just do that really quickly, and then I'll call it a day. And again, please ask me anything you want to know, no matter how big or small it is, right? So, all right, first of all, I need to change my context here as well. So I switched my context to the Kubernetes production cluster. It's kind of weird calling it that because there are two clusters just running on my local machine. And then I'm going to use the Flux CLI tool. And it's probably hard to read since it's, for some reason, figured out it's supposed to be blue on white. But anyway, so Flux is the CLI tool. Bootstrap is the command because we are bootstrapping our cluster. Makes sense so far. -- owner is my public organization. If you're testing this yourself on your own personal user, you also need to add a -- private, or personal, sorry, not private, personal, because that makes sense from an API standpoint at GitHub, I guess, something. So Flux needed to do that. Then we're setting the repository. It's called null to apps on Kates, just to be very short. We're setting the branch. If you don't do that, it will just use the main branch. And then we're setting the path, and we're not going to use clusters /dev. We're going to do clusters /prod. And hopefully it works. Looks like it's working. So what you don't see is that I set up my GitHub token as an environment variable, so I don't get asked about that. By default, that would mean that it's kind of tied to me personally. There are ways around that. You can set up SSH deployment keys manually, or you could use a GitHub app, for instance, stuff like that. But we can already see that we're already applying stuff, and we see the Kustomize, Helm, notification, and source controller that's already starting to get in and start running. So the thing is that we're not GitOpsing yet. This is just the Flux CLI tool doing kubectl apply on these components. When they are all up and running, that is when it's actually doing GitOps part. If I now look at KS, which is a shorthand for customization, I still have issues with that. I've had that the entire day and I couldn't figure out why. I probably need to update something, but I don't know if you do demos, but I don't update my machine right before I do a demo. That can go really bad. And again, since I'm doing no slides, that could go really, really bad. I also didn't record in the demos, so it could have gone bad anyway, but living on the edge. So we have our source controller, will soon be there. What we can do, since we don't have anything in our prod or error image pool, of course, just let it sit there, let it marinate. What can we steal? If we copy the entire web app folder to prod, and hold on. Oh, no. Speaking of demos, I'm going to do this because and now it's going to be black. I'm going to do this because for some reason, maybe not. Didn't I do the thing that I did? Okay, I probably didn't. Copy prod to. Copy prod to. Oh, that's the issue, right? Okay, I see. My mistake. To back. Isn't this correct? No. I'm not doing great, huh? Prod already exists. Oh, I see what I'm doing. At least that gave. Okay, never mind. At least this gave us time to get the Flux up and running on the cluster. So let's do this very simply by creating a manifest.yaml file. Let's steal something, because I don't want to write, because apparently I can't type at all. Let's go in here, and this looks really weird when I'm doing it like this. There you go. And we yank it, as they call it in the Vim world, and then we put it in, and I keep on forgetting to do that the right way. Anyway, we created a file. All right. If you haven't used NeoVim, this is kind of cool, by the way. You can use something like LazyGit and get a graphical interface for your Git, which is kind of cool. And I'm probably at time anyway. I'm probably at time. Okay, so let's just call it a day. Basically, that is a very speed-running way of doing application deployments in Kubernetes with some slight hiccups. And again, if there is anything at all, no matter how small or big, just come down and ask me afterwards, and we'll figure it out. Right, that's it.